Good morning, class. How are you?
Yeah, fine, thank you.
I'm good. You may have a seat. So today we'll be discussing about networking. What is computer networking and how it works in different topologies. So that's what we'll be finding out today. What networking is, the type of topologies of networks, the communication protocols, and the types of servers. Yes? Okay, to begin the lesson, we'll do a quick recap. Before we went for our break, we spoke of data communication. You guys remember we agreed that data communication is the electronic transfer of data, instruction, and information from one device to another. We said it involves sending devices, receiving devices, and transmission medium. We said there are some errors that can affect the data transmission, which can be electromagnetic interferences, noise, power failure, physical damage of the channels, or a lack of memory. We discussed all that, yes. We did also transmission media. We spoke of the physical media, which is the twisted pair cable and coaxial cable to the fiber optics. We spoke of the wireless transmission as well, the Bluetooth, the infrared, the microwave radio, and the satellites. Yes? So today we'll be continuing from there to networking. You all excited? Yes, okay. So let's start with networking. What is networking? Networking is a practice of connecting computers, devices, and transmission media. Computers, devices, and transmission media. In other words, we're connecting those three things. The process of connecting the computer, the other devices, and the transmission media. Right? To share, while we're connecting these three things, to share resources, exchange data, and communicate between each other. Okay? So there are different types of computer networks. We have the PAN, the LAN, the MAN, and the WAN. Personal area network, which is the PAN, the local area network, which is the LAN, and the metropolitan area network, which is the MAN, and the WAN, which is the wide area network. But in this lesson, we'll be discussing about the LAN, the WAN, and the MAN. We're not going to focus on the personal area network. Eh? Let's start with the local area network. The local area network connects computers and devices or nodes in small areas such as offices, homes, schools, or airport connections, connected using physical cables or wireless connections. Like for example, in your school, the type of networking connection you guys are using is called a LAN. A LAN, usually, the best way to identify a LAN, it usually is this guy, the switch. The LAN contains a switch. If you want to differentiate between the others, it always has a switch in the middle, which connects everything. So all the devices there are connected to one guy, which is the switch. Same applies to your school here. You're all connected to that switch that's in the whole of it. You understand? Yes. Let's move on to metropolitan area network. This one connects multiple LANs. Yes, multiple of LANs in an area such as a city or a town. It's able to do data communication among multiple organizations. For example, you can have two schools that are using the same resources. Maybe what they are teaching is what I'm teaching, but you're all connected to the same network. You're all connected to the same network. So a MAN is a combination of different LANs. A LAN there, a LAN there, a LAN there, and LAN there, and then it forms one network, and then we call it the MAN. It usually happens in the big cities or big towns. Then we have the wide area network, which connects multiple LANs and MANs in an area such as big cities, countries, or the world. This network is done by transmission media such as telephone lines, cables, satellites, and microwaves. A good example is the FNB, right? FNB banks. So the banks, when you're in SM, you're still able to access your banking details. When you're aware, you're still able to access your banking details because there are different branches, right? in other countries. So they are all communicating in one network. They're all using the same network, so that's different ones and ones combining together to form a wide area network. And the other example is the Google network. Google network is also a type of a one, since you can use the Google network wherever you are. Maybe you're in another country, and here we can edit the same thing. We're all connected to the same line, right? The good example of a one is an internet. The best example of a one is the internet, the wide area network. Moving on to network topologies. What is a topology? A topology refers to the physical layout, the actual how the computers are laid out of a network that involves the arrangement of the computers and the cables. For example, we have a star topology, we have a ring topology, we have a bus topology, and we have a hybrid topology. Now we'll be discussing those four topologies, and you'll see their differences and how each one connects. Let's start with the star topology. Now in this type of topology, all the devices are connected to a central hub or switch. Yes? The hub and the switch acts as a central point for data transmission. Now in this type of connection, a failure of one device does not affect the rest of the network. But a failure of the hub and the switch can disrupt the entire network. As you can see in this image, so you can see those two images. And these are types of star topologies. As you can see, the main thing they have in common is that they have this kind. They have this hub or switch here. This device there. That device is the one that acts as a medium transmission. So now if the switch or the hub gets damaged, the rest of the things cannot work. But if this guy is damaged, these three can still work. But if this computer gets damaged, these three can still work. That makes sense. If that computer damages, these three can still work. So this one, if any of these computers get damaged, but the others are working, they will still function. But if the switch or the hub gets damaged, everything else is off. Because the switch and the hub is acting as a central transmission medium. Moving on, let's move on to the ring topology. So for the ring topology, all devices are connected to a closed loop or ring. Data is transmitted in a single direction along the ring. Each device in the network acts as a repeater to boost the signal before passing it to the next device. A failure of one device can disrupt the entire network. So for a ring topology, this is how it works. When you are sending data or flow or a message, when you send it from one computer, it has to pass the other computer. We send from one device, it has to pass through the other device, and then the other device, and then the other device. Do you see that? So it forms something like a loop. So you're sending it in back and forth, back and forth. That's the difference between the ring and the star. The star has a central hub or a switch. The ring has to flow through all the devices in a loop. So each device boosts the networking, and then it goes like that. However, in the ring topology, if one device gets damaged, the whole flow is disrupted because it's supposed to pass through all the devices. Okay. Moving on. There are other examples of the ring topology. So these diagrams can come in different color, shapes, or whatever. You just need to know how the flow of information is going. Yes? But to do some examples after this. Moving on, bus topology. So the bus topology, all the devices are connected to a common backbone or single communication line. The data is transmitted in both directions along the backbone. A break in the backbone or a faulty device can disrupt the entire network. Yes? Now let's see this image for the bus topology. Bus topology. We'll be discussing the bus topology. In this status topology, all the devices are connected to a common backbone or a single communication line. The data is transmitted in both directions along the backbone. Yes? A break in the backbone or a failure or a faulty device can disrupt the entire network. In the bus topology, as you can see, that it looks like a bus. Did you see that? So they're all connected to one single backbone. They're all connected to this guy, and they're all taking from data from here, right? They're all taking from this guy. So it goes all the way, and then this one takes out, this one takes out, this one takes out, this one takes out, everything else takes out from that. Yes? You have a question? Which guy? The one in the middle. That's a laptop. It's called the backbone. It's called the communication line. It's called the communication line. Consider it as the backbone of the transmission. Yes? Okay. There we go. That's a full view of the picture that I showed you. The communication line, the different computers, and they are all taking from that communication line. So if one computer gets disturbed, the rest also not working. Yes. Moving on, the hybrid topology. So a hybrid is like a combination of different elements. The actual word hybrid, as a definition, is a combination of different elements. So in other words, when you're talking about hybrid topology, we're talking about different types of topologies being combined together to form one topology. For example, in this case, we have a star topology there, we have a ring topology there, and then we have a bus topology there, but they are all connected. You see here, the bus connects to the hub, and then takes it to the ring, and then it forms one topology, which we call a hybrid. Now, a hybrid can come in different shapes or forms. Eh? It can be a bus with a ring, it can be a star with a ring, it can be a star with a bus. It's all hybrid networking topology. There are other examples of hybrid topology. You can see there is a star. I see 1, 2, 3, 4, 5 stars. I see 5 star topologies and a bus topology. Right there in the middle. There's a bus topology here, acting as the main one, acting as the main backbone with a good communication line, giving transmission to the stars. Star topologies. Moving on, we'll have a small activity, class activity, I want us to discuss. So in that image, we're asked to identify the type of topology and the area network that is used to connect the above devices. So, what type of topologies do you guys see there? Yes, this. Yes, I also see a star topology. Why do you say this is a star topology? What do you see?
I see the switch and the other devices connected separately.
Yes, yeah, very much correct. Remember, a star always has a central switch or hub. So yes, she's correct. Which other connections you see, Marcelo? Okay, what do you see the bus topology? Yes, the router. The router is the one acting like the bus topology in this case. Yes. What about the type of area network? What type of area network do you guys see there? Remember we discussed the wide area network, and we said the best example of the wide area network is the internet. And so I see the internet there, I see a wide area network. Moving on, what about those ones? What type of topologies are those? Yes, yes. Is a what? Yes, the first one is a ring topology. What about the one on the sun you can see? What about the one on the right? What's an idea of that topology? Yes, please. Yes, that's the star topology. Are you guys who had different answers to it? You guys understand which one is which? Remember, the star has a central hub, but in this diagram here, there's no central hub. That's why it's not the star. Even though it looks like the shape of a star, it does not have any central hub connecting it. So it's not the star, it's a ring. And then we said in the ring, the data has to communicate to all the devices, so it has to pass through every computer. That's why it forms, and then it forms a loop. That's why it's a ring topology. What about that one? This one, yes, Cyclo? Yes, that one is a bus topology. Why are we saying it's a bus topology? Because it has a main backbone that's serving the rest of the computers. We call that backbone as a communication line. It's a main communication line providing data to the rest, to all the computers. How about that one? What kind of topologies do we have there? Yes, Marcelo, do you want to go show me which is which? Please show me which is which. Mm-hmm. Mm-hmm. Can you speak up a bit so we all hear? We have
a ring topology
yes.
and we have a star topology.
Okay, together it forms what type of topology?
A hybrid.
Yes, thank you, Marcela. So this is Marcela. So yes, that's a hybrid topology of stars, star topologies and ring topology. Type of topology and area network that are used to connect the above devices. So who can tell me what type of topologies you can see in that image? Yes? Yes? Mm-hmm.
I can see a star topology and also the bus topology, which means that there is it is the hub what? The hub is topology.
The hybrid topology, okay. Who else wants to try? Who else wants to try? You want to try? Who else wants to try? Who has a different answer? It's okay if it's wrong, then we'll give you the correct answer after. So just okay, first try. Okay, no one has a different idea. Okay, so I see star topologies. Why do I say I see star topologies there? Because these guys are connected to a hub, remember? These guys are connected to a hub. Here's a hub, and then the other devices connected there. So that is the star topology. That is the star topology. And then I see the router there, right? The router is connecting those three buses. Those two star topologies, sorry. Those two star topologies. So consider it as a bus. And then the type of networking there, remember, internet is the form of wide area network. Yes? So I also see the wide area network. Okay, moving on. The next slide. So we need to identify this type of topologies. So what type of topology is the first one? On the next.
It's a ring topology.
Okay, good. Why are you saying it's a ring topology? Do you have any idea?
This is because they are all connected into a ring formation, and the information is being transferred in
The same flow.
the same place. Yes.
So yes, you are correct. It's a ring topology, and the information is flowing through all the nodes, all the devices. So if you remove one device there, the whole connection is disturbed. What about the one on the right? Who has any idea of what type of topology is that? The one on your right? The one on your right? What type of topology is that on your right? We just discussed it right now in class. I cannot hear you. No, it's not a bus topology. Yes?
It's a hybrid topology.
Okay, why do you say it's a hybrid topology?
It has a switch and also the connecting.
No, actually it's a star topology. Remember we said a star topology always has a central, hub, or switch. Yes? So as soon as you see a central hub or central switch where all those devices are connecting to, you know already, this is a star. You can even see it's forming a shape of a star. But you must keep in mind, the main thing that you must keep in mind is that there's always a central hub in the middle or a switch. Yes? While the ring, you see the ring this side is also forming a star, right? But it does not have anything central. That's how you know it's, oh, this is a ring, because it's flowing the same way, but there's nothing in the middle. There's no switch, there's no hub or anything. Okay, moving on. The bus. Oh, I just gave you guys the answer already. What type of magnetic topology is that? It's a bus. I already told you guys the answer. So that is the bus topology. Remember the communication line, the terminal in the middle, and all the other nodes are connected to it. Okay, moving on, that one. What type of topology is that? Yes? Mm-hmm. Mm-hmm. Okay, who has a different answer? Yes? Try for us.
It's a hybrid topology.
Yes, it's a hybrid topology. So that is a hybrid topology because you can see the star, there you can see the ring, and then together it forms a hybrid topology. Okay, that's it for the class. I do have a little video here that I thought you guys might be interested in watching. Yes? Do you guys want to watch it?
Yes.
Unfortunately, network is failing us, but whenever you are free in the computer lab and you want to watch the video, I can give you guys the link, then you can watch it on your computers. Yeah, it's basically about network topology. But before we end the lesson, do you guys have any question? Did you guys understand? Maybe there's something you don't understand, you got confused somewhere. Do you have any questions? No one has a question? Should I assume that you guys understand?
Yes.
If you do not understand, can you ask your question? Because I have an activity for you guys after this. I want you guys to fill in the activity so I see if you guys understood the lesson. Yeah? I need my activity in the next lesson that we'll be having. That is tomorrow. Tomorrow. Yes? Okay. I had a video for you guys to watch, but to watch it during the next lesson. However, I do have an activity for you guys after this. You have a class activity. I told you guys to come with your a homework. I told you guys to come with your book. So I'll paste the homework for you guys later. And that was it for our lesson. So if you have a question, now is the time. Did you guys understand? Do you have questions? Are you confused somewhere? We all understood? We don't have any questions? Yes, please.
Yes, for the star topology,
Mm-hmm.
you said that if one device shuts down the rest,
Mm-hmm.
the rest will still work.
Yes.
For the bus,
Mm-hmm.
what if one breaks?
For the bus, if one breaks, they'll still work unless if it's the communication line. Remember, let's go back to the bus here. So if one breaks, the rest will still receive their data. But if the communication line, that one in the middle breaks, everything is off. Any more questions? Did I answer your question?
Yes.
Okay. Any more questions? We're all okay? Okay, so I'll show you guys the activity that we have to do in class. Do at home, sorry. It's a homework actually, it's not a classwork. Let me just open it for you guys. I'll print it out for you. You put it in your books and then you can do it in class. There is your homework. It's a multiple choice question. Answer all those questions and give me the right answer to these questions, yes? Okay, thank you for the lesson. Have a good day.